Hey students, welcome back to Vedantu NCERT Solution class 11th and 12th. This is Suhas Chemistry Master Teacher. Students, in this video we discuss the solution for the NCERT question 8.1. Come on students, let's move on to the question. The question is, what is meant by the following terms? Given example of the reaction in each case. First term, let's move on to the first term. The first term is cyanohydrine. What is the first term? Cyanohydrine. What is cyanohydrine? Cyanohydrine is an organic compound having the general formula R dash COHCN. The name itself denote, right students, one one cyanohydrine group with alcohol group. Okay students, here where R and R dash may be alkyl or aryl group. Okay students, let's move on to the another question is also there. Sub question, what reaction? We need to given one example, one reaction example each, right? How cyanohydrine is prepared? Cyanohydrine is formed by reacting ketones are reacted with hydrogen cyanide in the presence of excess of NaCN, sodium cyanide, to yield cyanohydrine. What is the general formula? General formula of cyanohydrine, this one, right? RCOHCN. Okay students, let's move on to the second one. What is second one? Second one is acetal. Okay, second one is acetal. Acetal is, these are the organic compound containing gem dialkoxy alkanes, containing gem dialkoxy alkanes at the terminal carbon consisting of two groups of alkoxy. At the terminal carbon consisting of what? Terminal carbon consisting of two groups of alkoxy. Two group of alkoxy is called acetal. Okay students, next move on to the reaction. The acetal is prepared by, the reaction between aldehyde and alcohol in presence of dry HCl gas, to yield hemiacetal. Hemiacetal is also there students in exercise. It is, I think, fifth one. And next, hemiacetal is reacting with another alcohol group to yield acetal. Acetal is nothing but this one. It's a gem alkoxy group, right? OR plus water. Understood students? Let's move on to the third one. What is the third one? The third one is semicarbazole. Next one is semicarbazole, right? Semicarbazole. These are also in compound having, these are also in compound, it's formed, these are also in compound, it's formed by condensation reaction, formed by condensation reaction between aldehyde or ketone with semicarbazide. Students, is important, semicarbazide to yield semicarbazole. Understood? Let's move to the reaction part. It's a condensation reaction with semicarbazide, right? Ketone, otherwise aldehyde ketone, we already know difference, right? In aldehyde there is no H group. In aldehyde there is H group, but in ketone there is no H group, right? It's a difference, and it's reacted with semicarbazide. Semicarbazide is nothing but NH2 NH C double bond O NH to yield. Here water molecule get eliminated and to form semicarbazone. Semicarbazone is nothing but this one, right? And NH C double bond O NH2. Understood students? Understood. Let's move on to the next one. Next one is aldol and hemiacetal. Okay. Next one is aldol. What is aldol? Aldol is a compound. Otherwise, aldol is a beta hydroxy aldehyde or ketone. Student, it is an beta hydroxy aldehyde or ketone. It's called aldol. Okay. Let's move on to the reaction part. The aldol is prepared by the condensation reaction between two molecule of ketone, otherwise aldehyde. Okay students, it's a condensation reaction between two molecule of ketone or aldehyde to yield aldol. Aldol is nothing but this one. CH, here OH bond is there, and it's reacted with another CH2 molecule and another CH2 molecule with CH3 CHO aldehyde group. Okay students, here H2O is removed. Okay student, understood? Okay, let's move on to the next one. Next one is hemiacetal, right? Next one is hemiacetal. Hemiacetal. This is also an organic compound containing alpha, what alpha alkoxy alcohol. These are the compound containing alpha alkoxy alcohols is called hemiacetal. We already know structure, right? OH group 1 and OR dash and ROH. RH. It is prepared by, next move on to the reaction part. Hemiacetal is prepared by aldehyde is reacting with one alcohol group in the presence of dry HCl gas. Dry HCl gas to yield hemiacetal, students. To yield hemiacetal. Understood? Next move on to the next one. The next one is oxime. Next one is oxime. Oxime. These are the organic compound containing general formula R-CnOH. This is a general formula of oxime. Understood, students? It's prepared by, how it's prepared? Okay, it is prepared by the condensation reaction, otherwise the reaction between ketone with NH2OH. Okay, NH2OH to yield oxime. Oxime is nothing but C double bond N OR NOH and here. Students, here one mistake is there, sorry. The general formula is RR-CnOH. Okay, students. Let's move on to the next one. What is the next one? The next one is ketal. Ketal. These are the gem dialkoxyalkanes. These are the gem dialkoxyalkanes. The structure of the ketone is, it's a very simple, students. We already know gem dialkoxy. Gem dialkoxy is nothing but OR group is attached to same carbon atom in same side. Okay, it's called gem dioxyalkanes. Okay, student, gem dialkoxy is nothing but OR and OR dash group attached for same carbon atom in same side. It's nothing but gem dialkoxanes. Okay, students, and next one to the reaction part. The reaction, the ketone is reacted with ethylene glycol. Ethylene glycol. Okay, ethylene glycol is nothing but 2OH group, students. 2OH group. The compound containing 2OH group is called what? Glycol in the presence of HCl gas to yield ketol. Okay, student, ketol is nothing but R dash and O. This O group is form and bond with CH2 group. Okay, the O group is form and bond with CH2 group. This is a compound. Let's move on to the next one. The next one is imines. Imines is very simple, students. Imines are the organic compound containing carbon and nitrogen double bonds. These are the organic compounds containing carbon and nitrogen double bonds. Let's move on to the reaction part. Before moving to the reaction part, let's discuss the structure. The structure of imines is this one. R dash R double dash. Where, students, if we represent R now, if is nothing but the R group may be alkyl, otherwise aryl. It may be. Okay, students, and let's move on to the reaction part. The imines are prepared by the reaction. It is a reaction between ketone with amine group. Ketone with amine group to yield imines. Okay, students. Let's move on to the next one. The next one is 2,4-DNP derivative. 2,4-DNP derivative is nothing but 2,4. It's nothing but 2,4 dinitrophenyl hydrazine or hydrazone. Phenyl hydrazine, otherwise hydrazone. Okay, students. It has a structure. This is a structure 2,4-DNP dinitrophenol. At 2,4 2 and 4 position nitro group NO2 group is present and it is an hydrazine NH2 group. Let's move on to the reaction part. What happened when 2,4-DNP is reacted with ketone or aldehyde to yield 2,4-DNP or 2,4-dinitrohydrazone, students. Hydrazone. Okay, students, what happened here? From this H2 and O, it's eliminated as a water molecule. Water molecule is eliminated, and finally this compound is formed. Here in hydrazone and C and N double bond is present with NO2 group at second and fourth position. Understood, students? Let's move on to the last definition. Last definition. What is the last definition? Skiff base. What is skiff base? Skiff base is very simple. These are the compound containing carbon and nitrogen double bond similar to the imines, but here one difference is there. For skiff base and imines, it is one difference is there. In imines, the R group may be hydrogen, otherwise any alkyl or aryl. If R group, if any alkyl or aryl, it becomes skiff base. If it is hydrogen, it becomes imine. Understood? The structure of this skiff base is R CH double bond and R dash. The reaction is the aldehyde or ketone is reacted with amine to yield skiff base. Understood, students? This is a solution for exercise 8.1. If you have any doubt, let me know on comment section. Question is, name the following compounds according to IUPAC system of nomenclature. We already know, right, IUPAC system. Come on, let's move on to the first compound. This is a first compound. In first compound, aldehyde functional group is present, and we already know IUPAC name is divided into three parts. One is prefix term, second one is parent carbon chain, and last one is suffix term. Suffix term is nothing but suffix refers to functional group. That's why, come on, let's move on to the first term. The first step is we need to count the carbon atom present in parent chain. Totally 1, 2, 3, 4, 5 carbon atom is present. That's why the name becomes pentane, right? Pentane. And let's move on to the numbering part. The numbering is taken place from the functional group side. That's why the numbering is taken place from right side. That's why the numbers become this, right? According to numbering, at first position the functional group is present, and the functional group is aldehyde functional group. That's why the suffix term becomes AL, pentanol, right? And let's move on to the prefix term. Here at fourth position the substituent is present, and the substituent is methyl substituent. That's why the name becomes 4-methyl pentanol. Let's move on to the second compound. In second compound, the functional group is present at left side. That's why the numbering is taken place from left side, and totally 1, 2, 3, 4, 5, 6 carbon atom is present in parent chain. That's why the name becomes hexane. And at third position, the numbering becomes like this, right? 1, 2, 3, 4, 5, and 6. At third position, the functional group is present. That's why hexane 3-ONE. Right? Why? Because ketone functional group is present. That's why the suffix term becomes ONE. And let's move on to the prefix terms. Here two substituents present. First one is Cl substituent, and second one is C2H5 is nothing but ethyl substituent. According to alphabet, C comes first. That's why the final name becomes 6-chloro. At fourth position, ethyl group is present. That's why 4-ethyl hexane 3-1. Understood, students? Let's move on to the third compound. In third compound, it is very easy. The functional group is present in right side. That's why the numbering takes place from right side. 1, 2, 3, 4. There are totally 4 carbon atom is present. 4 carbon atom is nothing but butane, right? But here double bond is present. Double bond is present at second position. That's why the name becomes but-2-en. And at first position, the functional group is present and aldehyde functional group. That's why the suffix becomes Al. but-2-en-1-al. Okay. The final name becomes finally but-2-en-1-al. Let's move on to the next compound. In next compound, the functional group is present in left side. That's why the numbering is taken place from left side, and totally 2 functional group is present, students. If we can numbering from right side also it's same, left side also is same. Okay, totally 5 carbon atom is present in parent chain. 5 carbon atom is nothing but pentane. But here 2 functional group is present at second and fifth position. That's why the final name becomes pentane 2,5 di ketone group is present. That's why the suffix becomes ONE, di-1. Understood, students? Let's move on to the next compound. Here next compound, the functional group is present at right side. That's why the numbering is taken place from right side. 1, 2, 3. This is an substituent term. Okay, 3, 4, 5. Totally 6 term is there. 6 carbon atom is there. 6 carbon atom is nothing but hexane, right? Hexane. And at second position, CO group is there. That's why the suffix term becomes hexane 2-ONE. And let's move on to the prefix terms. Here totally 3 substituent is present, but 3 are same substituent. That's why the name becomes trimethyl, right? Trimethyl. But We need to mention the position also. Position also very very important. Here at 3 2 methyl group is present and 5 1 methyl group is present. That's why the final name becomes 3 3 5 trimethyl hexane 2,1. Let's move on to the last compound, students. Here last compound carboxylic acid functional group is there and it's present at right side. That's why the numbering is taken place from right side. 1 2 3. Here only 3 carbon atom is present. That's why the name becomes propanoic acid. Why oic acid? Because carboxylic acid functional group is there. That's why the suffix term becomes OIC acid. Let's move on to the prefix term. Here 3 substituent is present at same position. Same position is trimethyl. That's why the final name becomes 3 3 3 trimethyl propanoic acid. Understood, student? The question is draw the structures of the following compounds. We already discussed IUPAC name. Similarly, we need to draw the structures. Come on, let's move. Let's move for the first compound. The first compound is 3-methyl butanol. Butane is nothing but 4 carbon, right? Butane is nothing but 4 carbon. 4 carbon. And which functional group is there? Aldehyde functional group. That's why C double bond OH. And at third position methyl group is there. 1 2 3. Here methyl group is there. Understood, students? Next last step. We need to fill the carbon valency with hydrogen. Okay, here already carbon valency is completed. Here another 2 electron is there. That's why we need to introduce CH2 group. Here 1 hydrogen we need to require and here 3 hydrogen. Okay, students, understood. Let's move on to the second one. The second one is para-nitropropionone. Student, para-nitro at para position nitro group is there and propionone. Phenone is nothing but this one, students. For benzene group C double bond O is attached. It's called phenone. Okay, understood. And it is pro is nothing but 3 carbon, right? Already 1 is there and here 2 and last one. And at para position nitro group is there. It's a prefix term, right? At para position nitro group is there. Students, para is nothing but opposite position and ortho is nothing but side position and meta next to the ortho position is called meta position. Okay, student, understood? If you have any doubt, let me know in comment section. And next move on to the third one. The third one is para-methyl benzaldehyde. It's very easy. We already know benzaldehyde. Benzaldehyde is nothing but for benzene group 1 aldehyde group is there. It's called benzaldehyde. At para position methyl group is there. Para is nothing but opposite position, right? Here methyl group is there. It's simple. Next, move on to the next one. The next one is 4-chloropentane 2-1. Pent is nothing but 5 carbon molecule. At second position ONE, at second position C double bond O group is there. That's why it becomes CH3 group. Understood, students? Next move on to the prefix term. At fourth position chloro compound is there. 1 2 3 4. Here chloro compound is there. Next, last step, we need to fill the carbon valency with hydrogen. That's why we need to put here 2 hydrogen, here 1 hydrogen and here 3 hydrogen. Understood, students? Let's move on to the next compound. Next compound is 4-methyl pent. Pent is nothing but same compound, it's 5. Pentane is nothing but 5 carbon. But here 2 group is there. One is double bond, another one is C double ONE is nothing but keto group. That's why here C double bond O, here CH3. Clear? Next, move on to the third position. First position, second position, third position, double bond is there. And at fourth position, methyl group is there. Next, last step, we already know. We need to fill the valency with hydrogen, right? Here CH3. Here already carbon valence is filled. Why? Here 2, 1, 3, 4. Here we need to introduce 1 hydrogen. It is a compound. It is a structure of the particular compound. Let's move on to the next one. The next one is 4-penyl pentanoic acid. Pentane. It's nothing but 5 hydrogen with carboxylic acid group, right? 5 carbon, students, sorry. 5 carbon with carboxylic acid group. It's clear? And at fourth position, phenyl group. Phenyl group is nothing but benzene group, student. If we remove one hydrogen from C6H6, we call that group as a phenyl group. Okay. At fourth position, 1, 2, 3, 4. Fourth position, we can C6H5. Otherwise, we need to withdraw that benzene group also. It's enough. Okay, it is also right. Okay, at third position, bromo group is there. 1, 2, 3. At third position, bromo group is there. Last step, we need to fill the valency with hydrogen. Here another hydrogen is required. Here also another hydrogen. Here 2 hydrogen. It's clear. Let's move on to the next one and the last one. The last one compound is para dihydroxybenzophenone. Dihydroxybenzo is nothing but diphenyl group. Okay, dihydroxy. This is an hydroxyphenyl. Okay, this is an hydroxyphenyl group. That's they also asked about ON is there. ON is nothing but ketone group. That's why here one ketone group is come and another dihydroxy is there. That's why another benzene group with OH compound. Understood, student? This is the solution for this exercise. And if you have any doubt, let me know in comment section. Write the IUPAC name of the following ketones and aldehydes. Wherever possible, give also common names. Okay, students? Wherever possible is nothing but for some compound they don't have any common name. That's why. Okay, students? Come on, let's move on to the first one. The first one is CH3CO CH24 CH3. First we need to count the carbon atom. Okay. CH24 is nothing but 4 carbon chain, students, not a substituent group. It is not a substituent group. It is also considered as an parent carbon. Okay, that's why the total number of carbon, how many total number of carbon is there in this compound? 2, here 4, 6 and 7. 7 compound. 7 is nothing but heptane, right? Heptane. But here functional group is there. Which functional group is there? Ketone functional group. It presents at second position. That's why heptane 2-1E. It's an IUPAC name. Let's move on to the common name. Common name and IUPAC name is both are different, students. For common name, the numbering is different. For IUPAC name, its numbering is different. Okay. According to common name, methyl group is there at what prefix? Methyl. And here ketone group is there. It takes place from suffix term same, but here totally 5 group. 5 is nothing but pentane, methyl, pentyl, ketone. It's a common name for this compound. Understood, students? It's a common name for this compound. Let's move on to the second one. In second one, come on. First step is we need to count the carbon atom present in the chain, right? 1, 2. This is become substituent. 2. This is become substituent, right? 2, 3, 4. 5, 6. Totally 6 carbon atom is present. That's why hexane. Hexane, right? Hexane. But at first position, CHOE group is there. That's why the suffix become AL. Hexanol. Okay. Hexanol. Suffix term is clear. Next, move on to the prefix term. Prefix term, here 2 substituent present, right? Here 2 substituent is there. One is methyl group. It's nothing but M term, M alphabet and bromo group. That's why bromo is coming first. That's why we need to mention first bromo, then methyl. That's why where bromo is present at 4th position. That's why 4 bromo, 2 methyl hexanol. Student, understood? Let's move on to the common name. Common name is different. I already tell you guys, common name numbering is different. For common name, we introduce the new terms alpha, beta, gamma. This term becomes alpha, this one becomes beta, this one becomes gamma. Okay, students? At gamma position, bromo group is there. That's why the common name becomes gamma bromo, alpha methyl carboaldehyde. Okay, student, what's not in carboaldehyde? Capraldehyde. Capraldehyde is nothing but its common name. Common name capro is nothing but removing these terms 1, 2, 3, totally 3, 4, 5 carbon is there. That's why the name becomes this. Okay, student, understood? Common name is different. Students, don't concentrate on common name. We mainly concentrate on IUPAC name. Don't worry. Okay, let's move on to the next one. This is the next one. Total how many carbon is present in carbon chain? Totally 1. CH2 is nothing but 5 carbon. Totally 7. 7 carbon is there. And at first position aldehyde group is there. That's why the name becomes. It is very easy. Heptanol. For this compound, there is no common name. Okay. Let's move on to the next one. The numbering is take place from this side, right? Totally 3 carbon atom is present. And at first position, aldehyde group is present. At second position, double bond is present. 3 is nothing but prop. Prop 2-en-1-ol. Okay, students. Suffix term is clear. Next, move on to the prefix term. Prefix term here, phenyl group is present at third position. That's why the name becomes 3-phenyl prop 2-en-1-ol. the common name of this compound is beta. It's nothing but alpha position, beta position. I already told you guys. I already tell you guys about the numbering in common system. In common system, we number as an alpha, beta, gamma, delta. That's thing. Okay. It is in format. Yeah, the for common name it's different. IUPAC name is different. Don't worry. Okay. I explain that. Beta phenyl. Beta phenyl ursulene. What is its name? Ursulene. Okay. Beta phenyl ursulene. Understood, students? Let's move on to the fifth compound. The fifth compound here, one cyclopentane group is there and carboaldehyde group is there. That's why here cyclopentane. Okay, cyclopentane. Pentane in the place of E, we need to introduce carboaldehyde. Cyclopentane carboaldehyde. It's an carboaldehyde. Carboaldehyde. Why it is called as an carboaldehyde? It's an why? Because it's an what? It's an common name. Let's move on to the IUPAC name. The IUPAC name of this compound is cyclopentane. At first position aldehyde group is there. Cyclopentane 1-ol. This is an IUPAC name. This is an common name. Okay, students, don't confuse here. Okay, next move on to the next one. The next one, the compound look like this. 2 pH group is there and one keto group is there. That's why the common name, not a common name, IUPAC name becomes diphenyl group. There are already diphenyl methanone. Methanone is nothing but there is only one carbon is there. There is no 3 carbon, right? Diphenyl methanone. For this compound, the common name is very simple, student. It is very, very important in your higher studies. If you go guys, next BSc, you take chemistry as a major subject. For most of the experiment, we use benzaldehyde in organic compound. It's a very important. Definitely, they ask the question from the benzaldehyde part. Definitely, students. Understood, students? This is about the NCERT question 8.4. If you have any doubt, let me know in comment section. Draw structure of the following derivative. Derivative is nothing but one compound is reacted with that derivative. We need to draw the structure of those. Okay. For example, the 2,4-dinitrophenyl hydrazone of benzaldehyde. First one, right? What benzaldehyde? We already know the structure of benzaldehyde. Benzene with aldehyde group. We already know about 2,4-DNP, right? 2,4-DNP derivative. What happened? The benzaldehyde is reacted with 2,4-DNP. The water molecule is get eliminated and it forms like this, right? NH and 2,4-DNP at second and fourth position nitro group. This is an derivative of 2,4-DNP. It's nothing but benzal derivative. Okay, benzaldehyde derivative. Next, move on to the cyclopropanone oxime. We already know about oxime group. C double bond and OH. This is an oxime group. Cyclopropane is there. Cyclopropane is nothing but cyclic 3-membered ring. Simple, students. Okay, let's move on to the next one. The next one is acetaldehyde dimethyl acetal. We already know about acetal. This one is acetal group. Acetal is nothing but this OCH3 group is called as an acetal group. They ask about dimethyl acetal. OCH3 already is there, and it is also asked acetaldehyde. Acetaldehyde derivative is nothing but acetaldehyde. We already know CH3 group. It's simple. Next, move on to the next one. The semicarbazone of cyclobutanone. First, we need to write butanone structure and semicarbazone. Semicarbazone is there. Semicarbazone is nothing but NH C double bond O NH2. This is a structure of semicarbazone cyclobutanone, students. Understood? Let's move on to the fifth one. What they ask? The ethylene ketal of hexane 3-on. Hexane 3-on. Hexane is nothing but 6-membered chain. 6-membered chain. At third position, ONE group. At third position, that ONE group is there. Okay, we need to write another carbon. Okay, next, what the ethylene ketal? The ethylene ketal, we already know ethylene ketal is nothing but OCH3. Here CH2, OCH2 in this is nothing but CH2 group. We already know about this. We already discussing 8.1, right? And next one, the next question is the methyl hemiacetal of formaldehyde. Hemiacetal structure. What is the hemiacetal structure? One OH group and here one H. Methyl hemiacetal is nothing but OCH3. Here R and H group will be interchanged. Here R group becomes H. Here this one group becomes R group becomes CH3, and this is about the structure of the methyl hemiacetal of formaldehyde. Clear, student? If you have any doubt, let me know on comment section, and please don't forget to like, share, subscribe the channel. Predict the product formed when cyclohexane carbaldehyde is nothing but cyclohexane group with aldehydic functional group reacts with the following reagents. First one is PHMgBr and then H3O please is nothing but Grignard reagent, right? Grignard reagent. PHMgBr. Grignard reagent. PHMgBr. The structure of cyclohexane aldehyde, this one, carbaldehyde, this one. It react with PHMgBr. What it gives? It gives this compound. What happened? Here, OMgBr and pH compound. What happened here? It become pH plus MgBr minus. Sorry, not pH minus and MgBr plus. It's reacted. Why? Because Mg is a metal bromide, right? Metal bromide is reacted with oxygen. It form a bond with oxygen, and pH is this minus molecule is reacted with this, and O gets shifted, and it forms the structure like this. Okay, it forms the product, this one. And next, they also ask with second step, H3O plus. H3O plus is nothing but hydrolysis. What happened in hydrolysis? This group is replaced by hydrogen. Hydrogen addition takes place, and finally the product become like this. OH. Sorry, students. One second. The final product becomes COH H pH. This is a final product. Cyclohexyl phenyl carbonyl. Right, student? Cyclohexyl phenyl carbonyl. Understood, student? Let's move on to the second one. The second one is Tollens reagent. What is Tollens reagent? We already know. What is the formula of Tollens reagent? Cyclohexane carbaldehyde. Sorry, it's a benzaldehyde. Okay. Students, for benzene and cyclohexane difference is in benzene we have alternate double bond, but in cyclohexane there is no double bond. Okay, here CHO, it's reacted with Tollens reagent. Tollens reagent is nothing but AgNH32OH minus. 2 molecule of Tollens reagent in the presence of H2O to balance the reaction, students. Okay, now it gives what? Aldehyde is converted into carboxylic acid, and with the liberation of Ag is nothing but silver image. We already know about Tollens reagent, right? It's nothing but silver image test to Ag with the liberation of NH3 molecule and 2 molecule of water. Okay, students, this is a balanced chemical reaction. Understood? Let's move on to the next one. The next reaction is with semicarbazide and weak acid. Okay, with weak acid is nothing but any acetic acid, otherwise anyone. Okay, weak acid is nothing but its pH value is above 3.5. Okay, students, semicarbazide, we already know the structure of semicarbazide. What is the structure of semicarbazide? NH2, right? NH2, C double bond O, NH2. This is the structure of semicarbazide. And cyclohexane carbaldehyde, CH4. What happened here? Oxygen and this hydrogen molecule liberated as a water molecule, right? H2O get eliminated, H2O get liberated, and it forms an product, cyclohexane carbaldehyde semicarbazone, right? In the presence of pH 3.5 weak acid, student, it's nothing but weak acid. Okay, it forms a product of this one, CH double bond NH, C double bond O, NH2. Understood, students? Understood? Let's move on to the next one. The product name is cyclohexane carbaldehyde, cyclohexane carbaldehyde semicarbazone, semicarbazone. Okay, students, let's move on to the fourth one. Fourth one is excess of ethanol and acid. Excess is nothing but it may be 2 molecule, otherwise more. Excess of ethanol. Cyclohexane carbaldehyde with excess of ethanol, CH2OH. Okay, 2 molecule of ethanol. This bond is not there, students. Okay, please don't confuse. This bond is not there. To explain the mechanism, what happened? One second. Yes. What happened? This OH molecule and this H molecule get eliminated to forms with the presence of, they also give with acid, any acid, with the presence of any acid to yield this compound. Diethyl acetal compound, student. Acetal compound we already know. Acetal is nothing but O compound. O here C. They give ethanol, not an methanol. Here confuses there. C2H5. Okay. C2H5. OC2H5. OC2H5 with H molecule. Understood, students? Let's move on to the last one. What is the last one? The last one is zinc amalgam and dilute HCl. Last one is zinc amalgam with dilute HCl. Okay, students, come on, let's discuss. Cyclohexane benzaldehyde is reacted with not a benzaldehyde, student, carboaldehyde. Okay, is reacted with zinc amalgam. Zinc amalgam is nothing but ZnHg in the presence of HCl or dilute HCl, right? Come on, let's check. As dilute HCl, in presence of dilute HCl, it yields. It's a very important reaction. Definitely they ask question from this exercise, students. Please concentrate. It yields methyl cyclohexane. This CHO group converted into CH3 group. In the presence of zinc amalgam aldehyde group is reacted. It's converted into methyl group. Okay, students. Methyl group. The compound name is methyl cyclohexane. Understood? Any doubt? Student, if you have any doubt, let me know on comment section. Which of the following compounds would undergo aldol condensation, which the Cannizzaro reaction and which neither? It's nothing but is under 9, totally 9 compounds. Which compound undergo aldol condensation, which compound undergo Cannizzaro reaction, and which compound undergo any other reaction? It's nothing but it does not undergo aldol condensation, also Cannizzaro reaction. Okay, students, which neither. And they also ask, write the structure of the expected products of aldol condensation and Cannizzaro reaction. Come on, let's discuss first one. Methanol. We already know for aldol condensation, aldehyde or ketone, it must be there one or more alpha hydrogen. Alpha hydrogen is nothing but next to the functional group, it must be one or more hydrogen group is nothing but CH2 group, otherwise CH3 group. In methanol, alpha hydrogen is there? No, it's not there. In 2-methyl pentanol, as absolutely pentanol, its alpha hydrogen is there. Hence, this compound undergo aldol condensation. Third one, benzaldehyde. In benzaldehyde, it is there? No. Benzophenone, as absolutely in benzophenone is also not there. Cyclohexanone, as absolutely in 5th compound aldol condensation takes place. Next, move on to the 6th compound. 1-phenyl propanone. Propanone is nothing but CCC is there. That's why in alpha position hydrogen is there, one or more hydrogen, hence it is also undergo aldol condensation. In phenyl acetaldehyde, it's any there acetaldehyde, as its acetaldehyde is nothing but, students, in alpha position CH3 group is there, and it is also undergo what? It is also undergo aldol condensation. And next, move on to the butanol. It's an alcohol. Alcohol undergo aldol condensation? No. 2,2-dimethyl butanol. Butanol is there. It undergo alpha. It is any alpha hydrogen is there? No. 2,2-dimethyl is there, student. Dimethyl butanol, its structure becomes different. That's why it is not undergo aldol condensation here. 1, 2, 3, 4. Totally 4 compound undergo aldol condensation. Let's move on to the Cannizzaro reaction. For Cannizzaro, I mark in different pen. Okay. For Cannizzaro, I mark in white pen. Okay. Methanol. For Cannizzaro reaction, what is the condition? Okay, for Cannizzaro reaction, the compound do not containing alpha hydrogen, it undergo what? Cannizzaro reaction easily add. That's why methanol, it undergo Cannizzaro reaction. And benzaldehyde, it's undergo Cannizzaro reaction, students. Yes, it's undergo Cannizzaro reaction. Absolutely, aldehyde compound, it's almost it undergo Cannizzaro reaction, not a ketone compound, right? And next, more to the benzophenone. No, ketone compound does not undergo Kenny-Zero reaction, we already know. Butanol, alcohol, no, it's not undergo. Here, 2,2-dimethyl-butanol is there as absolutely. It undergo Kenny-Zero reaction. Okay, next, we also choose neither benzophenol and butanol. It's benzophenol and butanol. These two compounds does not undergo any Kenny-Zero reaction, any aldol condensation. Why? Because students, in Kenny-Zero reaction, only aldehyde compound undergo Kenny-Zero reaction, but not an ketone compound, right? ON is nothing but ketone. And for aldol condensation, what is the condition? The condition is the compound must contain alpha hydrogen. We already know. That's why these two compounds does not undergo any reaction. That's why it is an OL is nothing but alcohol. Okay, student, understood. Let's move on to the they also ask, write the structure of the expected products. Next, move on to the aldol condensation of the product. First one what? First one is an 2-methyl pentanol. Okay, 2-methyl pentanol. 1 second, I change the 2-methyl pentanol. First one is 2-methyl pentanol. Okay, student, first aldol condensation we already know. First we need to write pentanol. First we need to write the structure of the compound. 2-methyl pentanol. At second position, methyl group is there. Pentanol. Pentan is nothing but 5-membered ring. Not in 5 members. Straight chain, right? Pentanol. At this position, AL is nothing but at first position. This one is there. At second position, CH3 group is there. Okay. Here CH2, CH3. Okay, students. 2 molecule undergo aldol condensation. Right? This aldol condensation is nothing but the compound react in the presence of dilute NaOH to yield. Students, let's choose this as an R compound. We can also choose as an R, and the final product become here R compound is there. Absolutely, here R compound is there. CHOH and COH, CH3 and another R group. R group is nothing but CH2, CH3 group, students. Okay, understood. The compound name is propyl heptanane. It forms propyl heptanane. Okay, understood. Let's move on to the second tab. The second, which compound undergo what aldol condensation? Here cyclohexanone. What is the structure of cyclohexanone? This, right? Cyclohexanone. This is a structure. It undergo aldol condensation in the presence of dilute NaOH. To yield this compound. What happened here? C bond get formed, and here one or more. For already know what is the condition for aldol condensation, students. At alpha position, 1 or more hydrogen must be present. That's why here 2 hydrogen is there, right? That's why this is the compound. The compound name is 2,1-hydroxy 1-cyclohexanyl cyclohexane 1 on 1 ON. Why? Because here at first position ketone group is there. Understood, students? Let's move on to the next compound. Which is the next compound undergo already 2-methyl pentanol done, and this one done. Next one is 1-pentyl propanone. Next compound is what, students? Next one is 1-pentyl propanone. Come on, let's discuss. 1-pentyl propanone. At first position, phenyl group is there, students, right? And next position, C double bond O, and what? CH2, CH3. We already know condensation reaction in the presence of dilute NaOH to yield what? Yield 3-hydroxy C here. CH2, CH3, right? CH2, CH3, COH and COH, CH, C double bond O, this one, right? Right, students? CHO, C double bond O, here another one, CH3 group is missing. H2O molecule get removed in the condensation process. This is a compound, right? The compound name is 3-hydroxy, right? 3-hydroxy 2-methyl at second position. 3-hydroxy 1 2 3, right? 1 2 3. 3-hydroxy OH group is there. 2-methyl second position methyl group is there, and 2-methyl what 1,3 diphenyl at first position, and third position diphenyl compound is there. Diphenyl pentane 1 pentane 5 carbon 1 2 3 4 5, right? Pentane 1 ONE. Understood, students? Let's move on to the next one. The last condensation reaction product, phenyl acetaldehyde. What is the structure of phenyl acetaldehyde? We already know about phenyl acetaldehyde. Phenyl acetaldehyde is nothing but one benzene group with CH2CHO compound. Two molecules of phenyl acetaldehyde undergo aldol condensation in the presence of dilute NaOH. Okay, it is very simple compound. It is also same, right? What? CH2, CHOH and CHOH and CHCH4. This one. The compound name is 3-hydroxy 2,4-diphenyl. This is 4 students. 2,4-diphenyl butanol. Why at first position aldehyde? 1 2 3 4. 4 compound. 4 carbon compound. 4 carbon chain. The main chain, the carbon chain containing 4 carbon atom, that is nothing but butane compound. At first position AL aldehyde functional group is nothing but butanol, and third position hydroxy group is there, and also at 2 4 position phenyl group, diphenyl 2 phenyl group is there. This is about aldol condensation. Next, move on to the Cannizzaro reaction. In Cannizzaro reaction, how many compounds undergo Cannizzaro reaction? Totally 3 compounds. One methanol, and second one is benzaldehyde, and last one is 2,2-dimethyl butanol. First one yaudu? First one is methanol, right? First one is methanol. What is the structure of methanol? Methanol AL. AL is nothing but aldehyde functional group. What is Cannizzaro reaction? Cannizzaro reaction is very simple, right, students? What is Cannizzaro reaction? Cannizzaro reaction is nothing but what? AL group is nothing but aldehyde group. Aldehyde group in the presence of concentrated NaOH, otherwise concentrated KOH, it yields alcohol, methanol. What is the structure of methanol? C double bond O H H. It's reacted. It's undergo reaction with concentrated NaOH to yield alcohol. CH2OH. CH2OH, right? Not an CH2. We need to balance the chemical. We need to fill the reaction, right? Here, CH3OH is nothing but methanol. It yield methanol. Okay, with the liberation of sodium methanate. Methanate is nothing but HCOONA. Students, here I write HCOONA. Okay, students, let's move on to the next one. Next compound undergo Cannizzaro reaction. The next compound is what? 1-phenyl propanone, right? 1-phenyl propanone. As students, no. It is aldol condensation. Benzaldehyde. Benzaldehyde. What is the structure of benzaldehyde? This is right. This is the COH. 1 second, I write neatly. Sorry, students. Benzaldehyde is nothing but COH group. It undergo reaction with concentrated KOH. Okay, students, with 2 compound, what it yields? It yields benzyl alcohol. Benzyl alcohol is nothing but CH2OH group with potassium benzonate. Potassium benzonate is nothing but one benzyl group with C double bond O. Okay, understood, students? Let's move on to the last Cannizzaro reaction, which is the last compound undergo Cannizzaro reaction is 2,2-dimethyl butanol. Butanol is nothing but butane 4 member, 4-CCC. Students, last compound, come on, let's discuss. According to butanol, right? CCH3, CH4 here. CH2, CH3, S. 2 molecule, it undergo reaction with in the presence of concentrated NaOH. This is a difference between Cannizzaro reaction and what? Aldol reaction. In aldol condensation, we use dilute NaOH. In Kenny-Zero reaction, we use concentrated NaOH and KOH. It's a strong concentrated base. Okay, students, what it is? It is alcohol. CCH3, CH3, CH2, OH and CH2, CH3. Understood, students? With the liberation of sodium, C double bond O, sodium compound, right? Sodium methanate compound. CCH3. What is the name of the original name of this compound, students? Come on, let's discuss the name. The numbering is taken from this side. 2, 2, sodium 2, 2 dimethyl butanoate, right? Sodium 2, 2 dimethyl butanoate. Understood, student? How will you convert ethanol into following compound? AL is nothing but ethanol. What is the molecular structural formula for the ethanol? It's CH3CH4, right? What they ask? First one is butane 1,3-diol. OL is nothing but alcohol. 2-di-alcohol. Okay, students, how it will be formed? How it will convert? The first step, we already know aldol condensation is nothing but the compound undergoing condensation reaction in the presence of dilute NaOH. What it yields? It yields 3-hydroxybutanol, right? What it is? CH3, CHOH, CHOH, CH2, CHO. It is 3-hydroxy. It is 3-hydroxybutanol, right? 3-hydroxy what? Butanol. Next, but they want butane 3-1-ol. Next step is very easy step. Next, 3-hydroxybutanol undergo reduction in the presence of sodium NaBH4. Okay, NaBH4 reduction to yield 1,3-diol. Okay, 1,3-butane 1,3-diol. CH3 COH. 1 second, student. CH3A. CH3COH and CH2CHO. Understood, students? Understood reaction? Let's move on to the second one. The second one is butenol. ENAL andre it's nothing but what is the structure of butane? CCCC. At first position C double bond OH group. At second position double bond. This is an final product. Okay, how it will be converted from ethanol? The structural formula of the ethanol is CH3CH4, right? First step is same, student. First step is what? Same. Condensation, aldol condensation reaction to yield same compound CH3 CHOH. Next CH3CHOH what? CHCH4, right? First step is same as the same compound CH2CH4. Understood? Same step, students. But we need what compound? We need butane 2-enol. For this, simply eat the compound, remove water molecule. What happened? Here H2O molecule get eliminated and form. Here one molecule of H and OH molecule. This term is eliminated and forms the compound CH3CH double bond CHCHO. Understood? But2-en, what is the final name? 2-en-al. Understood, students? Let's move on to the next one. The next compound, the next one is butane 2-enoic acid. We already know the aldehyde is reacted with in the presence of Tollens reagent to yield benzoic acid, right? We need but2-enoic acid. It's nothing but this step is common for the next one also. This step is common, and for this step CH3CH for this compound CH3CH CHO it undergo reaction in the presence of Tollens reagent. Tollens reagent is nothing but AgNH3 2 plus OH minus, right, to yield the final product but2-enoic acid, right? But2-enoic acid CH3. The final product is CH3CH double bond CHOOH. Understood, students? Write structural formulas and name of 4 possible aldol condensation product from propanol and butanol, and also in each case indicates which aldehyde acts as nucleophile and which as electrophile. Understood, students? Come on, let's move. We already know aldol condensation. What is aldol condensation? The enolite ion reacts with aldehyde group to yield beta hydroxyaldehyde, right? This is a reaction. First move on to the propanol compound. What is the structure of propanol? CH3 CH2 CHO, right? It undergo aldol condensation in the presence of dilute NaOH to yield hydroxy alcohol in the beta position, right? It's a very simple CH2, CH3, CHOH, right? CH3, CHO. This is a structure. Let's move on to the next one. Next one, what? Butanol. Next butanol compound. Butanol compound is nothing but CH2, CH3, C double bond OH compound. It undergo aldol condensation in the presence of dilute NaOH. It undergo aldol condensation in the presence of dilute NaOH. It yields beta hydroxy butanaldehyde, right? Hydroxy butanaldehyde. The final compound becomes, let's choose this as an R part, R C double bond O, not an C double bond O, sorry students, COH, CH and CH, CH2, CH3, CHO. Understood students? Next, and also they ask 4 products. Already 2 is done. Next, move on to the next one. The next one, the aldol condensation reaction between both propanol and butanol. But we choose 2 different conditions. In the first condition, put propanol acts as an electrophile and butanol acts as a nucleophile. In next condition, reverse. Okay student, understood? Next one is the aldol condensation reaction between propanol and butanol. Propanol is nothing but CH3, CH2, CHO plus CH3, CH2, CHO in the presence of dilute NaOH, right? But students, here the choosing of an electrophile and nucleophile is different for both different for 2 conditions. Okay students, in first condition, this acts as an what? This acts as an electrophile and this acts as an nucleophile. What it will become? The product become CH3, CH2, CH, OH and CH, CHO, CH2, CH3. Okay students, the name of the compound 1, 2, 3, 4, 5. 5 is nothing but pentanol, right? Aldehyde, AL, aldehyde pentanol, and at 1, 2, third position hydroxy group, second position ethyl group. That's why H come first, right? E, B, C, D, E, F, G, H, E is come first. That's why 2 ethyl, 3 hydroxy pentanol. Understood students? Let's move on to the next one. The next one is same, but here electrophile and nucleophile is interchanged. Here electrophile is CH3, CH2 butanol, okay? Electrophile is butanol and nucleophile is propanol. That's all students. It's a very easy reaction. CH2, CHO. It undergo aldol condensation reaction in the presence of dilute NaOH to yield what it yield here? CH3, CH2, CH2, CHOH is there, enol, right? Enol, and the new aldol bond is formed. The condensation bond is formed between the compound CH, CHO and CH2. Come on, name the compound. CH3. 1, 2, 3, 4, 5. Pentanol. PANTA. NaL. At second position, methyl group is there, and at third position, hydroxy group is there. That's why 3 hydroxy, 2 methyl pentanol. Understood students? An organic compound with a molecular formula C9H10O. What? C9H10O forms 2,4 DNP derivative. Also, it reduces Tollens reagent and undergo Kenisor reaction on vigorous oxidation. It gives 1,2-benzene dicarboxylic acid. Identify the compound. What is the molecular formula of the compound? The molecular formula is C9H10O. Okay students? The compound, what they give, the compound forms 2,4-DNP derivative and it is also reduces Tollens reagent. That's the compound must be an aldehyde. From this first, what it will become from? The compound is an aldehyde, but the molecular formula is C9H10O. The compound may be this, right? CHO and CH2CH3. Why? Because students, here this thing is happened and also it undergo oxidation. In the Kenisor reaction is nothing but the compound react with concentrated NaOH to undergo vigorous oxidation to give 1,2-benzene dicarboxylic acid. It's nothing but CHO group is directly attached to the benzene, and that's why the compound is this one. Come on, let's check the molecular formula is same or not. Here 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbon is there. Totally 10 nitrogen. It's nothing but here 1, 2, 3, 4, 4, 5, 6, 7, 8, 9. 10 is there. This is a compound. Okay, student, understood? If you have any doubt, let me know on comment section. An organic compound A. On organic compound A with a molecular formula what? C8H16O2 was hydrolyzed with dilute sulfuric acid. Hydrolyzed is nothing but H2O added, water added, right? In the presence of dilute H2SO4, what happened to give two compound? One is carboxylic compound and carboxylic acid compound, another one is alcohol, and also they give oxidation of alcohol with chromic oxide. And what? Dehydration. Dehydration is nothing but removal of water. It gives but1ene. Student, it is nothing but but1ene is nothing but it's an 4-membered compound. Alcohol is an 4-carbon compound. 4-carbon compound. It's nothing but carboxylic acid is also 4-membered. It's nothing but what happened when A compound A undergoing hydrolysis. Hydrolysis, it give 4-membered carboxylic acid group and 4-membered alcoholic group. From this data, what will be confirmed? The compound is ester. The compound is ester. That's why its molecular formula becomes this one, right? Ester is nothing but this one. Here we need to mention 3 carbon atom. Why? In first part we got B carboxylic acid, 4-membered carboxylic acid. That's why here CH2, CH2, CH3. It's nothing but 3-membered ring, 4 compound already there. And another side, we need to mention another 4 carbon atom, CH2, CH2, CH2 and CH3. Understood, students? Let's move on to the, they also, what they ask about equation for the reactions involved. First reaction is dehydrolyzed reaction. Not an dehydrolyzed, it's an hydrolyzed reaction. In the presence of dilute H2SO4, what happen? It yields 2 compound. First one is carboxylic acid compound. It's nothing but butanoic acid, CH2, CH2, C double bond OOH, CH3. It's an first compound. And alcohol, butanol, CH3, CH2, CH2OH. Understood, students? Let's move on to the next equation. Next one is alcohol undergo oxidation in the presence of chromic oxide, CrO3. Alcohol, CH3, CH2, CH2OH. Butanol undergo its two reactions. First one is undergo oxidation in the presence of chromic oxide. Right? What happened here? It yields carboxylic acid, CH3, CH2, C carboxylic acid, right? CH3, CH2, C double bond O. Okay, students? Understood? Here another 1 carbon atom I missed here. Okay. Understood? Next move on to the next reaction. Next reaction is what? Dehydration. Dehydration reaction. Dehydration is nothing but removal of water molecule. What happened? Here but1ene is formed. CH3, CH2, CH double bond CH2. 1, 2, 3, 4. There are 4 carbon atom is there, and at first position double bond is there. That's why the final compound name is become but1ene. Understood, student? The question is arrange the following compounds in increasing order of their properties indicated. Come on, let's move on to the first one. They give 4 compounds. 1, 2, 3, 4. First one is an aldehyde compound. Let's choose an B. Acetone for B, C and D. What they give? Reactivity towards HCN. In HCN compound, we already know the attacking nucleophile is Cn minus. It's a negative charge. It contains negative charge. It's nothing but the compound have high positive charge. It have high reactivity towards the Cn minus compound. It's nothing but the compound contain negative high effect. Negative high effect is nothing but electron withdrawing group. The compound containing electron withdrawing group having high HCN, having high reactivity towards HCN. Here there is no negative group is contains, but the compound containing plus high effect, it decreases the reactivity towards HCN molecule. We already know, right? According to this, the first compound becomes ditertiary butyl ketone. Why, students? What is the structure of ditertiary butyl ketone? It's nothing but C double bond O, CH, no, not NCH2. 1 second. Yes, CH3. Here what happened? This CH3 molecule acts as an electron donating group. These groups donates the electron towards this compound, and that's why it becomes negative charge. That's why the reactivity towards HCN is low. Next, compared to that one, second one, methyl. Same compound, students. This is a compound for option D. This is a structure for option D. That's why, compared to this, absolutely, the reactivity towards HCN is low. Next compound, acetone. Here acetone 2CH3 group is there, and in acetaldehyde only one group is there. Understood, students? Let's move on to the second one, acid strength. We already know the acid strength depends upon the C double bond OO minus stability. This COO minus stability. According to this, the compound containing electron donating, not an electron withdrawing group have high acidic strength. It's an easy topic. Here totally, let's choose A, B, C, D. In compound A and compound D, it contains electron withdrawing group. Right? That's why it have high acidic strength. Compared to these two here, the substituent 3-methyl group present at same carbon. That's why compared to D, C has high plus high effect. Otherwise, C has high negativity. Right? It gives high electrons towards the central carbon atom. Right? That's why it becomes, first one is C. C has very low acidic strength compared to D, and here two compound bromine group is there, but this bromine group is directly attached to the next at beta position, right? C double bond, here CH2 molecule is there. For C molecule, Br is there. It present at beta position or second position after the functional group, but here it present at alpha position. That's why next compound is B. A. Compared to B, A has high acidic strength. Let's move on to the next one. Here also acid strength same. The compound containing electron withdrawing group have high acidic strength. Here 3,4-D dinitrobenzoic acid there and 4-nitrobenzoic acid there. Let's numbering as A, B, C, D for 4 compound. According to electron withdrawing group and electron donating group, 4-methoxy is nothing but CH3 group is there. Right? Methyl group, 4-methoxy, OCH3 group is there. Methoxy is nothing but OCH3 group. That's why D comes first. Next one, benzoic acid comes second. Next move on to this B, C. Both are having high acid strength only, but compared to B, C has high acid strength because why here 2 nitro group is there, students. It withdraw the electron greaterly. It's withdraw the electron compared to this. It has high capacity to withdraw the electron. Why? It contains 2 nitro group. That's why the reactivity order becomes D, A, B and C. Understood, student? If you have any doubt, let me know on chat section. And please don't forget to subscribe the channel. Question is, give simple chemical test to distinguish between the following pairs of compound. First pair. The first pair is propanol and propanone. Propanol is nothing but aldehyde compound. Propanone is nothing but ketonic compound. Ketone compound, right? Ketone compound. We already know from tolerance test. What is tolerance test? Tolerance test is nothing but if any compound is reacted with tolerance reagent, it shows silver mirage. We already know aldehydic functional group shows positive response for the tolerance state, but not an ketone group. Right? From tolerance test, we can easily distinguish between propanol and propanone. What happened if propanol is nothing but CH3, CH2, CH4, right? Is reacted with tolerance reagent. What is tolerance reagent? AgNH3 2 plus OH minus. It yields silver image with release of ammonia compound and water compound and very important ion compound CH3 CH2 COO minus ion, right? Propanate ion, right? Next, move on to the second one, acetophenone and benzophenone. Both are ketone group only, but here we already know what is the structure of acetophenone, student. Acetophenone structure is this one, right? It's contain acetophenone, the compound containing 1 CH3 group, but in benzophenone, both sides the compound containing 2 phenyl group. Benzophenone is nothing but, what is the structure of benzophenone? This, right? The structure of benzophenone is this. How to distinguish between acetophenone and benzophenone? We already know from iodo form test. Iodoform test, we can easily distinguish acetophenone and benzophenone. How iodoform test is shows positive for acetophenone? We already know. If the compound is directly, if the CH3 group, the compound containing CH3 group is directly attached to the functional group, it gives yellow PPT. The compound is reacted with iodoform reagent. It shows yellow PPT. Iodoform reagent is nothing but sodium hypoiodide, right? Come on, let's discuss with reaction. This is the structure, molecular formula of acetophenone, right? COCH3. If it's reacted with NaOI is nothing but sodium hypoiodide. Sodium hypoiodide, right? It is sodium ethonate. Sodium ethonate. What happened here? This sodium molecule replaces what? CH3 molecule, and it yields CH3I. What? Iodoform. It yields iodoform and sodium hydroxide with releases of sodium hydroxide. Understood, students? Understood? It's clear? Let's move to the next pair. The next pair is phenol and benzoic acid. What is the difference between phenol and benzoic acid? In phenol, the compound containing only OH group, but in benzoic acid, oic acid is nothing but carboxylic acid group. It contains C double bond OOH. From which test we can easily identify, students? From ferric chloride test. From ferric chloride test, we can easily distinguish phenol and benzoic acid. What happened if phenol is reacted with ferric chloride? For example, C6H5OH is reacted with ferric chloride. It yields what it yields? Iron phenol complex is nothing but it yields violet color. It gives violet color of iron phenol complex. What is the structural formula of iron phenol complex? CO C6H5 okay, 6 and 3 minus with HCl compound plus HCl. To balance the reaction, we need to introduce here what? We need to introduce here 6. Okay, and next move to the benzoic acid. What is the formula, molecular formula of benzoic acid? The molecular formula of benzoic acid is C6H5COOH. If it's reacted with ferric chloride, it yields ferric benzoate. It's an buff color. This is violet color. This is buff color. What is the molecular formula of ferric benzoate? What is the molecular formula of ferric benzoate? It is C6H5COO3 Fe, iron molecule, with liberation of HCl molecule. Okay, students, let's move to the next pair. The next pair is benzoic acid and ethyl benzoate. Benzoic acid and ethyl benzoate is nothing but here the 8 is nothing but ester group. Oic acid is nothing but carboxylic acid group. We can differentiate these two by sodium bicarbonate test. We already know, right, students? Benzoic acid is nothing but C6H5COOH. Benzoic acid is reacted with sodium bicarbonate. It gives sodium ethonate, and with the liberation of CO2 gas. We can easily confirm CO2 gas by lime water test. What happened if we pass CO2 gas to lime water? Through lime water turns milky. It's nothing but C6H5COONA. Sodium methonate is formed with the liberation of CO2 gas. Sodium, what it formed? Sodium methonate, series not an methonate, sodium benzonate is formed. Sodium benzonate, and with the liberation of CO2 gas. And ethyl benzoate is not reacted with sodium bicarbonate, right? It does not give reaction with sodium bicarbonate. It's nothing but no CO2 gas is liberated. Understood, student? Let's move on to the next pair. The next pair is pentane 2,1 and pentane 3,1. Students, what is the structure of pentane 2,1? Pentane is nothing but 5 carbon, CH3, CH2, CH2, and at second position functional group is there, right? In pentane 3,1 at third position functional group is there. We already know about iodoform test. We already discussed iodoform test in this exercise only. In this before differentiation before differentiate to pair compound, right? What is iodoform test? When iodoform test give reduce or give positive response if the CH3 group, if the methyl group is attached to functional group carbon, it shows positive. Iodoform test is nothing but it yields what? It yields CHI. What? Iodoform. Iodomethyl it yields. What happened if this reaction is reacted with iodoform test is nothing but sodium. What? Sodium water, NaOH, sodium hypoiodate. It's reacted with sodium hypoiodate. It yields sodium ethonate. Not an ethonate, it's an propanate, sodium propanate, CH2COONA with the CHI3 with the iodoform. Right, students, next move on to the next pair. The next pair is benzaldehyde and acetophenone. Aldehyde and phenone group. We already discussed in first one. We can easily differentiate these two pair by tolerance test. What happened if the benzaldehyde is reacted with tolerance reagent? It shows positive response, not an acetophenone. Why? Because ketone group does not show any positive response for the tolerance test. What happens? What is the structure of benzaldehyde? Benzaldehyde structure is C6H5CH4. It's reacted with tolerance reagent. Tolerance reagent is nothing but AgNH3 2 plus OH minus. It gives silver image with the liberation of C6CH5 COO minus ion with what? With silver image. With silver image is shown. Right, students, let's move on to the last one. Ethanol and propanol. It's a very easy, students. How it will be differentiate these two pairs. From iodoform test, we can easily differentiate these two. Why? Because we already know what is the structure of ethanol. Ethanol structure CH3 C double bond OH, but propanol CH2 CH3 C double bond OH. Here methyl group is directly attached to the carbon containing functional group C double bond O group, right? That's why ethanol shows positive response for the iodoform test, but not an propanol. What happened if ethanol is reacted with sodium NaOI? It shows LOPPT. It forms an LOPPT. We already discussed. CH3. What? Here what happened? Not an CH3, student. At COONA with liberation of CHI3 molecule and NaOH molecule. Right, students? Understood? Student understood? If you have any doubt, let me know in comment section. How will you prepare the following compounds from benzene? You may use any inorganic reagent and any organic reagent having not more than one carbon atom. Okay, understood the question? First one, methyl benzoate. What is the structure of methyl benzoate? We already know methyl benzoate. For this one, C double bond O CH3. This is the structure of methyl benzoate. They give starting material. The starting material is benzene group. First step is bromination. We already know what is bromination. Benzene undergo reaction in the presence of bromine to yield bromobenzene. This is an first step, student. Understood? Second step, Grignard reagent. We already know how Grignard reagent form. If the compound is reacted with metal in the presence of ether, it yield Grignard reagent. MgBr. RMgX. We already know about Grignard reagent, right? RMgX. Next step. If we already know we need COO group, ester group. Benzone ethonate is nothing but ester group. That's why the next step, Grignard reagent undergo reaction in the presence of dry ice. Dry ice is nothing but CO2 group. What it yield? It yield benzene group with C double bond OMgBr. The next step is hydrolysis. What happened if the compound undergo hydrolysis? This MgBr is replaces by hydrogen to yield benzoic acid. But we need methyl benzoate. That's why we already know what is esterification, student. The esterification is nothing but the acid, any acid. The acid is reacted with ethanol to yield ethonate. It yield ester. This reaction is called esterification reaction. Next step is esterification reaction. If It's reacted with methanol to yield methyl benzoate. Understood, student? COOCH3. First step is bromination. Second step is Grignard reagent. It's nothing but magnesium, the compound. Next step is the reaction with magnesium in the presence of ether. Third step is dry ice. And fourth step is hydrolysis. And last step is esterification. Let's move to the second one. The second one is metanitrobenzoic acid. We already know benzoic acid. Up to till the step is same. Up to till the procedure is same. First step is bromination. First one is bromination, student. It yield bromobenzene. Next one, it reacted with magnesium in the presence of ether. Second step, MgBr. Next, it's reacted with carbon dioxide. Is nothing but dry ice to yield COOMgBr. Next step is hydrolysis. H3O plus it to yield benzoic acid. We already get benzoic acid, but we need metanitrobenzoic acid. This is ortho position, meta position. We already know COOH is an electron withdrawing group, not a donating group. That's why nitration. What is nitration? Nitration is nothing but the compound undergoing nitration in the presence of HNO3 and H2SO4. It yields nitrobenzoic acid, but we already know COOH group is an electron withdrawing group. That's why nitro group is attached here. Understood, students? Let's move to the third one. The third one is para-nitrobenzoic acid. Para-nitrobenzoic acid is nothing but it attached at para position. But for this, the procedure is different. We try with a new steps. Okay. First step. We already know starting material is benzene. What is Friedel-Crafts alkylation reaction? Friedel-Crafts alkylation reaction is nothing but benzene is undergo reaction in the presence of CH3Cl or anhydrous aluminum chloride to yield toluene. Students, to yield toluene. It's a very important reaction. Definitely they ask question. Next step. Next, nitration. Nitration is nothing but HNO3. The reaction, the compound undergo reaction in the presence of concentrated HNO3 and concentrated H2SO4 to yield metanitrotoluene and another also yield orthotoluene. Why? These are ortho and meta oriented group, but this is minor compound. Ortho compound is minor, but this para compound is major. Next step is filterization. We need to take metanitrobenzene. Why? Para-nitrotoluene. Why? We need to prepare para-nitrobenzoic acid. That's why we need to take para-nitrotoluene. Next step is undergoing the compound para-nitrotoluene undergoing reaction in the presence of KMNO4 and KOH. What happened? It yield para-nitro. Heat. CH3 group is replaced by C double bond OK, YK potassium tonate, and with para position nitro group is there. Last step, hydrolysis. If it's hydrolysis the compound, we can easily get para-nitrobenzoic acid. Okay, student, understood? These are the steps. First step is what? Friedel-Crafts alkylation. Next one is nitration and filterization. Next, to get COOK compound and hydrolysis. Understood? Next, move on to the next compound. Phenyl acetic acid. What is the structure of phenyl acetic acid, student? Phenyl acetic acid is nothing but for benzene group. CH2 group is there. It's called phenyl group. CH3 group. COOH is attached to CH2 group, not and direct attached to benzene group. Students, it is a very easy reaction. We already know what is the starting material. The starting material is benzene. We already know about the starting material. First step, same student, Friedel-Crafts alkylation. Friedel-Crafts alkylation to yield toluene compound. It's reacted with AlCl3, right? Aluminum chloride, otherwise CH3Cl. Next step, bromination reaction in the presence of NBS. NBS is an reagent. The NBS, what is the full form of NBS is N-bromosuccinamide in the presence of H nu or del. It yield bromo compound CH2Br. Next step, it reacted with alkaline KOH, it yields what it yields? Benzyl cyanide. Benzyl bromide undergo reaction in the presence of alcohol KOH to yield benzyl cyanide. And the last step, hydrolysis. If hydrolysis the benzyl cyanide, we can easily get what? Phenyl acetic acid. What happened here? Here CH3CN group is there. This CN group, CN is nothing but C triple bond N group. This C triple bond N group is replaced by COOH group. CH2 COOH. Next, move on to the next compound and the last one, para-nitrobenzaldehyde. This is a structure. What is the structure of para-nitrobenzaldehyde? At para position, nitro group is attached, and here C double bond O. C double bond O aldehyde group. Students, first the starting material is benzene. First step is common, student. First step in Friedel-Crafts alkylation in the presence of AlCl3 and or CH3Cl to yield toluene compound. To yield what? To yield toluene compound. Next step. What is the next step? The next step is reacted with nitrate. Toluene undergo nitration. The nitro group is attached to. It is attached to what? Para position. Why CH3 group is an electrodonating group, students? Already para nitro position is clear, but we need to obtain aldehyde function. We need to convert CH3 group to aldehyde group. In next step, the para nitro toluene is reacted with CS2 or CrO2Cl2 to yield this compound. This is a compound, okay? In CH3 position, it CHOCrOHCl2. Okay, students? Cl2. And last step is hydrolysis in the presence of H plus or water to yield para-nitrobenzaldehyde. Understood, student? If you have any doubt, let me know on charts, let me know on comment section. How will you bring about the following conversion in not more than 2 steps? Okay, first one, propanol to propene. What is the structure of propanol? It's a three-membered carbon compound, C double bond OCH3. This is the structure of propanol. ONE is nothing but ketone group. Next, we need to convert it to a double bond alkene compound. First step is propanol undergo reduction using NaBH4 or any reducing agent. What it yields? It yields alcoholic group CH3 COH but we need propene. From alcohol we can easily obtain propene, right? We can easily obtain propene. Alcohol undergo reaction in the presence of concentrated H2SO4. Alcohol, it undergo reaction in the presence of concentrated H2SO4 to yield propene compound. What is the structure of propene? CH3 CH2. What happened here? H2O molecule get eliminated. Okay, students, let's move on to the second one. Benzoic acid to benzaldehyde. What is the structure of benzoic acid? This is the structure of benzoic acid, right? For one phenol group, COH group is attached. It's a very simple benzaldehyde. We already discussed in previous exercise also. First step is benzoic acid undergo reaction in the presence of SOCl2 to yield chlorosubstitute compound, C double bond OCl compound, right? Next step, but we need benzaldehyde. It undergo palladium catalytic hydrogenation in the presence of palladium barium sulfate to yield benzaldehyde compound. It's a very easy, students, and definitely for JEE NEET, definitely from this chapter, this type of reaction question is 100% there. Okay, students? Come on, let's move on to the next one. Ethanol to 3-hydroxybutanol. What is the structure of ethanol? CH3CH2OH. We need 3-hydroxybutanol. First step, it's very easy. Oxidation in the presence of any oxidizing agent. It yield as CH3CH4. It yield acetaldehyde. Second step, but we need 3-hydroxybutanol. How to obtain 3-hydroxybutanol? It's an VZ from aldol condensation in the presence of dilute NaOH to yield 3-hydroxybutanol. What is the structure of 3-hydroxybutanol? 2 compound of this undergoing reaction to yield this one, right? Understood? Next, move on to the fourth one, benzene to metanitroacetophenone. So many times we already discussed what is the structure of benzene. This is first step is Friedel-Crafts alkylation. Benzene undergo Friedel-Crafts alkylation in the presence of anhydrous AlCl3 in anhydrous AlCl3 to yield acetophenone. We already discussed in next exercise also. We discuss Friedel-Crafts alkylation. Don't worry, students. Next step, but we need what? Metanitroacetophenone. Next step is very easy step. We already know CO is an electron withdrawing group and it is an meta-orienting group. That's why we need metanitration. If the compound acetophenone undergo nitration in the presence of HNO3 and H2SO4 to yield metanitroacetophenone. Understood, students? Come on, let's move on to the fifth one. Benzaldehyde to benzophenone is nothing but aldehyde group to ketone group. What is the structure of benzaldehyde? This is the structure of benzaldehyde. CH4. First step is HNO3 is nothing but oxidation. What happened? It undergo oxidation to yield aldehyde function group is converted into carboxylic acid functional group. But we need ketone group. Second step is very easy. Second step is we need to benzoic acid undergo reaction in the presence of SOCl2 to yield chlorosubstituting compound. C double bond OCl. Before exercise we already discussed. And next step is, but we know benzophenone. Next step is Friedel-Crafts alkylation in the presence of benzene to yield benzophenone. What is the structure of benzophenone? C6H5, C double bond O, C6H5. Okay, student, come on, let's move on to the next one. Bromobenzene to 1-phenyl ethanol. Bromobenzene. Benzene group, bromo group is attached. What is the first step? First step is bromobenzene undergo reaction in the presence of magnesium and ether to yield RMGBr, Grignard reagent. Correct? Yes, it's need Grignard reagent. And next step, we need 1-phenyl ethanol. That's why the next step is bromobenzene or phenyl bromobenzene, phenyl what? This group, RMGBr group, undergo reaction in the presence of CH3CH4 acetaldehyde and H2O molecule to yield 1-phenyl ethanol. 1-phenyl ethanol. CHOHCH3. Understood, students? Understood? Any doubt? Let's move on to the next one. What is the next one? Next one is benzaldehyde to 3-phenyl propanol. OL is nothing but alcoholic group. First step is very simple, student. Benzaldehyde is reacted with acetaldehyde in the presence of NaOH to yield this. Okay, to yield the compound. Next, this compound undergo reaction in the presence of nickel palladium catalyst, or otherwise catalytic hydrogenation reaction to yield the compound 3-phenyl propanol. Propanol is nothing but CH2 3 group, CH2OH, right? Propanol. Next, move on to the next one. The next one is benzaldehyde to alpha hydroxyphenyl acetic acid. What is the structure of benzaldehyde? This is the structure of benzaldehyde. First step is simple. It undergo reaction in the presence of NaCN or in the presence of HCl to yield COH and CN compound. Understood? Next step is very easy. Hydrogenation. H plus ion in the presence of H3O plus to yield C6H5CH. We need alpha hydroxy at alpha position hydroxy group and phenyl acetic acid. Phenyl acetic acid is already there. CHOH, COOH. Come on, let's naming. Carboxylic acid. Acid's clear. Acetic acid. At alpha position, hydroxy group is there and also phenyl group is also there. Understood? Let's move on to the last one. Benzoic acid to metanitrobenzyl alcohol. Student, what is the structure of benzoic acid? This is the structure of benzoic acid to metanitrobenzyl. First step, it's very easy. It undergo reaction in the presence of LiAl H4. Lithium aluminium hydride. What is the role of lithium aluminium hydride? It's an reducing agent. What happened? It formed alcohol group, CH2OH group, right? C benzoic acid structure. What is the structure of carboxylic acid too? It reduces alcohol. And next step, we need metanitrobenzyl alcohol. Metanitro, we already know this group is electron withdrawing group. Why here OH group is there? That's why it's an meta direction group. HNO3 in the presence of H2SO4 nitration to yield metanitro what? Metanitrobenzyl alcohol. This is this solution, students. Describe the following. First one is acetylation reaction, Cannizzaro reaction, cross-orbital condensation, decarboxylation. Right, students? Come on, let's move on to the first one. Acetylation. What is acetylation? The name itself it indicates acetyl group is added. What? Acetyl group is added. Otherwise, the inorganic compound, the acetyl group is introduced. Acetyl functional group is introduced. Is called acetylation. What? Inorganic compound, the acetyl functional group is introduced. The acetyl functional group is introduced is called acetylation reaction. For example, alcohol is reacted with what? With acetyl chloride, CH3COCl in the presence of base like pyridine. Why here we use pyridine as a base, students? Because in the place of H, we need to introduce acetyl group, right? Acetyl is nothing but CH3 group, right? That's why pyridine is helps to take a protein out from the compound. It yield what? It yields CH3, CH2, right? CH3, CH2, what? COOCH3. Right, students? What it yield? Ethyl acetate. Ethyl, not acetate. What? Ethyl acetate. It yield ethyl acetate plus HCl. Understood? This is called acylation reaction. Let's move on to the next one. Cannizzaro reaction. We already know about Cannizzaro reaction in previous exercise also. What is Cannizzaro reaction? Cannizzaro reaction is the self-disproportionation is the proportionation is nothing but oxidized and reduced. Right, student? A reaction of aldehyde with no alpha hydrogen in alpha position with no alpha hydrogen is called what it's called? Cannizzaro reaction. Right, students? What is Cannizzaro reaction? Is nothing but the aldehyde compound contain no alpha hydrogen is reacted with concentrated KOH to yield what it yield? Alcohol and carboxylic acid. What happened? For example, aldehyde. Choose any aldehyde with no alpha hydrogen. It's nothing but this one, right? Acetal. What? Acetaldehyde. Let's take an example of acetaldehyde. It undergo Cannizzaro reaction in the presence of concentrated alkalis, concentrated base, right? Concentrated KOH to yield first two compound. One compound aldehyde reduce to give alcohol CH3CH2OH, and another molecule of same aldehyde group oxidized to give carboxylic acid CH3COOK. Understood, student? This reaction is called Cannizzaro reaction. Let's move on to the next one. The next one is cross-orbital condensation. It's a very easy reaction, right, students? Cross-orbital condensation is nothing but it is a reaction. Cross-orbital condensation is a reaction between two molecule of aldehyde or two molecule of ketone, or one molecule of aldehyde or one molecule of what? Aldehyde or one molecule of ketone to yield four products, students. To yield cross-orbital condensation. If the both compound containing alpha hydrogen, it yields four products. Okay, students. In the presence of what? In the presence of any base, it yields what? Four product if it presents alpha hydrogen. For example, reaction between propanol and ethanol. Ethanol is nothing but CH3, CH2, CH4 plus. This is propanol, student. Ethanol, CH3, CH4, ethanol and propanol, to yield 4 products. I already explained in the presence of base NaOH to give 4 products. First 2 are self-aldol condensation and another 2 products are cross-aldol condensation. Self-aldol condensation is nothing but the product is formed by 2 molecule of same compound and 2 molecule of propanol compound and 2 molecule of aldol compound, and in next step from 1 molecule of aldehyde compound and 1 molecule of ketone and vice versa, right? What are the product? The product is give first one is butan 2NR CH3 CH double bond CH CH4. It is sealed by 2 molecule of what? Acetal compound, and second one CH3 CH2 CH CCH4 CH2, right? This is sealed by, these are called self-aldol condensation product, because this product is yielded by self-condensation of propanol molecule. This product is yielded by self-condensation of what? Acetal molecule. Next, another cross molecule, students, cross aldol condensation molecule. What they give? By this molecule and this molecule, CH3 C double bond C CH4 CH3, and second one similarly CH3 CH3 pentan 2NOL is formed, students. Pentan, this is one pent, 5 carbon is there. At second position double bond is there, and first position aldehyde functional group is there. Here at second position as well as both CH3 substitution group and double bond is also there. That's why its name becomes 2-methyl. I write here 2-methyl but2-enol, right? Next mode, the last one, decarboxylation. It's a very simple reaction. The name itself, it denotes decarboxylation. The removal of CO2 group from carboxylic acid compound is called decarboxylation. The removal or the release of CO2 compound. The release of CO2 compound to yield hydrocarbon is called decarboxylation in the presence of sodium. Soda lime is nothing but sodium salts are heated with soda lime. Sodium salts are heated with soda lime is called decarboxylation. For example, sodium ethonate in the presence of sodium soda lime. Okay. To yield, this CO2 group is removed and form as an CH4 molecule, methane molecule with the Na2CO3, sodium carbonate. Right, students? This is about the solution for the NCERT question 8.16. The question is, complete each synthesis by giving missing starting material, reagents or products. Okay, come on, students. Let's move on to the first one. Here, what reagents are there? Reagents is there and first starting material is there, but we need to identify product. What happens, student? What is KMnO4 in the presence of KOH? What is this reagent? This reagent acts as an oxidizing agent, right? What happens? This CH2COH3 group undergo oxidation to yield what it yield? It yield pot benzoate, right? What? In the place of CH2CH3 COOK. It's converted into a carboxylic acid group. The name of this compound is pot benzoate. Right? Understood? Second one, SOCl2. SOCl2, we already know it's a chlorinating agent. What happened? This OH group is replaced by chloro group. Why? OH group is also divalent. Oxygen is a divalent compound. Chlorine is also divalent. To yield chloro substituent compound. COCl. Understood? Let's move on to the third one. Here, NH2CO, NH2 is there. It is an semicarbazide. We already discussed in previous exercise, students. Aldehyde is reacted with semicarbazide is to yield semicarbazole compound. What it yields? C6H5. Here water molecule get eliminated from this O compound and H2O compound. CH double bond N. Right? CH double bond N. And here another NH molecule is there. And NH CONH2. Benzyl semicarbazone. What is the name of this compound? Benzaldehyde semicarbazone with carbazone with the with water liberation. Let's move on to the fourth one, right? Benzene is converted into what? Benzyl acetone, right? Benzyl acetone group, benzophenone group, right? Benzophenone. Here reagents are missing. We need to attain. We need to give an specific reagents here, right, students? We already know Friedel-Crafts alkylation, right? What is Friedel-Crafts alkylation? Benzene is reacted with benzyl chloride in the presence of what? In the presence of anhydrous AlCl3 to yield benzophenone. It's nothing but this is an Friedel-Crafts alkylation. In the reagents place, we need to introduce benzyl chloride and anhydride AlCl. Next, move on to the fifth one. We already familiar this tolerance test. What happened here? Mirror image is taken and COO minus ion is formed. COO minus ion with the Ag mirror image. Right? Let's move on to the next one. What is the compound name? What is the compound name of this? 2-formyl. At second position, formaldehyde group is there. 2-formyl benzoic acid. It reacted in the presence of NaCN. NaCN is nothing but sodium cyanide. What happened? Here cyano group is attached to yield this compound. Cyano group is attached. C H is normal is there. OH and Cn. Right, students? And COOH group is already there. The compound is same. What is the name of this compound? At second position, this group is there. What is the overall name of this compound? At the first position, CH group is hydroxy cyanomethyl benzoic acid, right? Methyl. Why? Because here only one carbon compound is there. That's why its group becomes benzene. Sorry, not a methyl group. Methyl benzoic acid. Right, students? Next, move on to the seventh one. We already in previous exercise only we discussed. What is this? Listen, CC cross aldol condensation. What happened to yield this one molecule and this molecule is cross condensation. CC cross aldehyde condensation, and here in this position C6H5CHO in alpha position. Here hydrogen is also there. That's why it gives 4 product, but the major product is this one, 2-methyl, right? What happened? C6H5CH double bond CCHO with CH3. Come on, let's name it. 3 compound is there. At second position, methyl group, 2-methyl. At third position, phenyl group is there, 2-methyl, 3-phenyl. Pro. At second position, ENE group is there, 2-ENAL. Aldehyde group, right? Next, move on to the next one. NaBH4. We already familiar with this reagent, right? What is the use of NaBH4? It acts as a reducing agent. What happened? This CO group converted here hydrogen atom H2 molecules get added to yield the final product. This one CHOH C double bond O is converted as OH group, right, students? We are already familiar this type of reaction. What is the final name? The final name is ethyl 3-hydroxybutanate. Butanate. Why? At first position, ethyl group is there. At the third position, 1, 2, 3. No, 1, 2, 3. Yes, 1, 2, 3. Third position, this group. At first position, C2H5. Ethyl group is there. 1 ethyl, 3 hydroxy. At third position, hydroxy group. 1, 2, 3, 4. Totally 1, 2, 3, 4. 4 carbon is there. That's why it's the compound name. Right? Let's move to the next one. Next one, it's very easy. What is the role of CrO3, students? We already familiar this with CrO3 reagent. It's an oxidizing agent. What happened? This compound is the alcohol compound. What happened here? Hydrogen group is eliminated and double bond O is formed. Cycloketone is formed. Ketone group is formed. Cycloketone group. Okay. Next. Here the compound is converted into aldehyde compound. The double bonding compound is converted into aldehyde compound, right? Here reagents are missing. We already familiar this reaction. First we need to broke this double bond. That's why we introduced BH3. What is the role of BH3? This is broke the double bond and form this compound. In first step, it forms CH2B. And next step, we need to remove this B. We boron, BH3, borohydride, right? Borohydride, we need to remove this. That's why we use H2 or H2O2 or H plus. Next, third step, PCC. What is the role of PCC? It converts the molecule into aldehyde group, right? Understood? Let's move on to the last one. O3 ZnH2O. What is the role of O3? It's an oxidizing agent. But students, please read the question here. 2 molecule is there. If instead of 2, it is 1 is there, the answer is this one. Cyclo-alcoholic group. We can easily, cyclohexanol we can easily mention. But here 2 molecule is there. That's why we need to understand the question. That's why the compound become here 2 compound is there, right? 2 compound is must and should be there. That's why the compound name become this. What is the compound name? The starting material, this one, cyclohexyl diene compound, diene cyclohexane. Understood? If you have any doubt, let me know on comment section, student. The question is, give plausible explanation for each of the following. First one, we need to explain why it's not happening. In first one, cyclohexanol. What is the structure of cyclohexanol, students? This is an structure of cyclohexanol. Forms cyanohydrine in good yield. Cyanohydrine is nothing but it reacts with NaCN or HCN to yield OHCN compound. OHCN compound. This is an cyanohydrine group, right? In good yield, but 2,2,6 trimethyl cyclohexanol. 2,2,6. It's nothing but at second position 2 methyl group. 1, 2, 3, 4, 5, 6. At sixth position, only 1 methyl group. Does not, if it undergoes cyanohydrine, it does not form any reaction. Why? Because student, here, please see, here there is no alpha substitution is there. In this compound, there is no steric hindrance. No steric hindrance. And this is forms cyanohydrine in good yield, but in this compound, alpha substituted methyl group is there. That's why this methyl group produces steric hindrance. Steric hindrance. That's why 2,2,6 trimethyl cyclohexanol does not forms cyanohydrine. Cyano group, CN group is not substituted. Y group. Why, students? Because this CN group, NaCN or HCN, okay? NaCN or HCN. This cyano group in HCN, CN minus group has a nucleophile. That's why in this compound, CH3 group or electrodonating group, we already discussed. That's why it's not formed. Second one, let's move to the second one. The second one is, there are 2 NH2 groups in semicarbazide. We already know that what is the structure of semicarbazide. This one is right, NH2, NH2, right? Here, 2 carbazide. However, only one is involved the formation of semicarbazone. Why? Because in this one NH2 group are involved in what? Involved in what? In resonance. This and the lone pair in nitrogen compound is involved in resonance to yield what? This is in resonance. NH2 plus CO minus NH2, right? This is in resonance. That's why this NH2 group, it's not acts as a nucleophile. That's why this group acts as a nucleophile. That's why only one group is involved in the formation of semicarbazone. Why? Because one group is involved in resonance. That's why only one group is accessed. Understood, students? Let's move to the last one. The last one is during the preparation of esters from a carboxylic acid and alcohol. For example, any alcohol, ethanol, C2H5OH and CH3COOH. It yields ester, right? C2H5COOCH3, ester. And water. In the presence of acid catalyst, the water or the ester should be removed as soon as possible, as soon as it formed. Why? Because it's a very easy solution, student. This is a reversible reaction. If we don't remove water or ester, it reversely formed. It forms what it forms? Reactant. It forms reactant. It's a reversible reaction. That's why we need to remove. Otherwise, ester or water. Okay, student, understood? This is the solution for the NCERT question 8.18. If you have any doubt, let me know on comment section. The question is, an organic compound contains 69.77% of carbon, right? And 11.60% of hydrogen. And remaining is oxygen. Come, let's calculate the percentage of oxygen first, okay? Before moving to the question. Oxygen 100 minus 69.77 plus 11.63. If we calculate this, we can approximately get 18.63%. And they also give its molecular formula, not a molecular formula, mass 86. From 86, we can easily identify the molecular formula. Come on, let's check from the percentage. What is the ratio? What is the ratio of carbon is present in the molecule, hydrogen, and let's check that. Okay, the ratio it's become 69.77 divided by what is the atomic mass of carbon is 12. And approximately 11.63 divided by 1 plus 18.63 divided by 16. Finally, 12 is around 5 point something, and 110, 111 and 1. Okay, but they already mentioned 86. That's why if we introduce C5H11O, but it's not matchable for 86. Why? 12 is a 60, 60 plus 16, 76 plus 11. It's not. That's why we need to remove 1. Why? Because hydrogen mass, it's above around 1.12 something. If we divide that, we can get 5:10. Okay, students. Finally, the molecular formula of the compound is C5H10OS. Come on. And they also give, it does not reduce Tollens reagent. It's nothing but it's not an aldehyde. The compound, it is not an aldehyde. Compound, it is not an aldehyde. As it's clear, students. Next, what they give? They give what they give, and it gives positive ionoform test. We already know positive ionoform test is nothing but in alpha position, one CH3 group is must be there. It's nothing but it may be methyl ketone, and we need to match the structure with C5. We need to write 5 thing at alpha position. It's clear. Next, fill the hydrogen with respect to their valency. The structure, the compound is pentanone. Why? Because it's a ketone group. Understood? Pentane to 1, right? Sorry, 1 second. What is the name of the compound? Pent, it's a ketone compound, it's a methyl ketone compound. Understood? Okay, student, understood? The compound is this. Why? Because if it vigorous oxidation, it gives ethanoic acid and propanoic acid. What happened? This compound, ethanoic acid, is nothing but 2 C double bond CH3 COOH is formed. Similarly, CH2 CH3 OH is formed. COOH is formed. Understood, students? Propanoic acid is formed, and also this one, propanoic acid is nothing but COOH and CH2 CH3. Clear? Understood? The compound, the probable structure of the compound is this one. It's an pentane to 1. Compound is pentane to 1. Understood? If you have any doubt, let me know on comment section. Although phenoxide ions is nothing but this is the structure of phenoxide ion, right? Has more number of resonating structures than carboxylate ion. Carboxylic acid is stronger acid than phenol. Why? Come on, let's draw the all possible structures of the phenoxide ion. What happened? This bond, it move like this. This is a first resonating structure. Here positive charges come. Second one, here no positive charges come, students. Why? Because already it have negative charge. Its valency is already satisfied. Second one, the bond is move and negative charge is moved towards. Right? Next possible structure. What is the next possible structure? The bond is move and this thing happen. it forms here minus charge, here double bond O, right, here double bond O. Next, last possible structure, this bond is moved, and the last structure. These are the possible resonating structure of the phenoxide ion. Let's move to the next compound. Carboxylic acid ions is nothing but C double bond O minus R group. What happened? What is the possible structures? These are the two possible structures. These are the two possible structure of the carboxylate ion. What? Resonance structures, right? Carboxylic acid compound. But here, please watch students here. In these two compound, in both compound, oxygen carries negative charge. But these 5, only 2 compound, oxygen carries negative charge. It's nothing but these 3 resonating structures are eliminated. Compared to carbon, oxygen have a high ability to hold the negative charge, right? Negative charge. Why? Because we already know we need to do another 2 minus electron already. In oxygen, totally 6 electron is there. It's not possible compared to carbon 4. That's why carboxylic acid is stronger acid than phenol acid. Why? Because in this compound, in both oxygen atom carries negative charge, but here only 2 resonating structure, in 2 structures carrying negative charge. That's why these 3 resonating structure are eliminated. That's why compared to phenol, carboxylic acid as an high is an strong acid compared to phenol. Understood, student? If you have any doubt, let me know on comment section, and please don't forget to like, share and subscribe the channel. Thank you so much.